Hey fam, let's go and look at this question 8 on our screen. It's this is trigonometry, as you can see, and it involves it's trigonometry involving 2-dimension, 3-dimension, as you can see here. All right, we're given that in the diagram, BC is a diameter of the circle. So if BC is a diameter of the circle, that simply suggests to us that angle D is 90 degrees. It suggests that to us. Then we are given that B angle CD is theta, as you can see here. A angle CB, it's alpha, and AB equals to BC, whilst BD is given by P. The length of BD, it's P, right? So we need to go and provide the answers of these 4 questions, as you can see. Then the first question, 8.1, they say write down with reason the size of angle D. That has to be 90. Because of a semicircle. So 8.2, they say we should express BC in terms of P, in terms of R, theta and what, and P. So you are just standing here. This is your opposite over hypotenuse. We're going to use sine of theta, sine theta. And that will be opposite, which is P, over hypotenuse, which is BC. And quickly, this one will be P over sine theta. That's for 2 marks. Then 8.3, they say we should find the size of angle B1. We should find the size of angle B1. Clearly show what all your calculations. So what we can do firstly here, we'll say angle A will be alpha. Reason being opposite angles equal sides. So this one will also be alpha. So B1, no need to provide the reason. You can see the question here. No need to provide the reason. So B1 plus angle A plus A angle CB, that will be equals to 180. Sum of angles in triangle. B1 is what we're looking for, plus angle A, which is alpha, plus alpha equals to 180. And at last, B1 will be 180 minus 2 alpha minus 2 alpha. Okay, now looking at 8.4, they say we should prove that AC, which is this one here, must be equals to this one. So how can we do so? We'll say, okay, we'll use sine rule to say AC over sine angle B1, which B1 already we have is that one here. All right, so let's do so. We'll say AC, we're looking for AC over sine of B1 equals to BC over sine A. This is where we start. Then let's substitute AC over sine B1, which is 180 minus 2 alpha. Okay, this equals to BC over sine alpha over sine alpha. Yes, sine alpha. So from here, let's cross multiply. We're going to have AC equals to BC sine 2 alpha all over sine alpha. All right, so now we can say AC equals to BC times this one here. We'll have to apply the grade 12 rule here. Grade 12 rule states that for double angle of cos, let me write it here for the grade 11s to be familiar with it. So if you have sine 2 alpha, according to double angle of sine in grade 12, this is the same as 2 sine cos. I'm only writing this for the sake of grade 11s to understand. Meaning that where there's this one here, we'll replace by 2 sine alpha 2 sine alpha cos alpha over sine alpha. Then we're going to have our AC here equals to, where there's BC, we're going to have this, right? P over sine theta. So P over sine theta. But let's remember that sine alpha will cancel sine alpha. What must we have after cancellation? That will be 2 cos alpha all over 1. And finally, as we conclude this one, AC will be equals to 2p cos alpha over sine theta. And that is that. I hope you've enjoyed. Don't forget to subscribe, like the video, also share amongst your friends. Until we meet again next time, guys. Love you all. Bye.